Hi there, welcome back to this video. So in this session, we want to continue with our exam review. We want to revise GC Mathematics Paper 2, Section A. So I've already made a video where I solved quite a number of questions from Section A, Mathematics Paper 2. So I just want to continue and solve more questions. By the way, if you have not watched the first video, I'll pin the link in the comment section so that you can access that video. Let's just get started and answer the questions together. Okay, so the other topic that you need to understand and know how to solve questions on is something called probability. Okay, so let's see what sort of questions we expect to find in the exam. So let's answer this question. This question will help us revise through probability. Okay, so the question says, a boy has 7 red and 2 green balls in a bag. He picks a ball from the bag at random and does not replace it. He picks another one. So this boy has these 7 red balls and 2 green balls. He picks without replacement, then he picks again. Okay, so the first part says draw a tree diagram to show or to illustrate all the possible outcomes. Then find the probability that the 2 balls picked, remember this person is picking 2 balls. The first one he picks, he does not replace, then he picks another one. So find the probability that the 2 balls picked are both green, have the same color. So what are we supposed to do? Okay, so the first question is very important. Okay, it's very important. You need to understand and know how to draw a tree diagram in probability questions. So let's learn together how to draw a tree diagram. Let me do this. Okay, so what we know, let's collect the data. So what we know is that we have 7 red balls. So 7 red and 2 green. Okay, then in total, you can see that in this bag, we have a total of 9 balls. So we have 9 balls in this bag. Then this person picks at random. Okay, so it's a random experiment. So this person picks at random. Then we are asked to draw a tree diagram to illustrate the possible outcomes. So a tree diagram is basically a diagrammatic way. Okay, it's a tree that will show all the possible outcomes, all the possible chances that can happen. Okay, yeah, that is a tree diagram. So it's just a tree because it will have some branches. So it's a tree or a diagrammatic way to visualize all the possible outcomes. So what are we supposed to do? Because we only have 2 types of balls here. We have red balls and green balls. It means that our tree should only have 2 branches. So our tree will only have 2 branches. If you had 3 types, your tree will have 3 branches. What I mean here, our tree will look something like this because we only have 2 types of balls here. If we had 3 types, it will look something like this. If you had 4 types, it will look something like this. Just like that. Okay. I hope you get the idea. Now let's understand how to draw this tree diagram. So this tree diagram, you don't just draw it, you also show the probabilities. Okay. Let me just draw this and explain to you. Okay, so what do we do here? So this is what we do. We're going to start with the first picking. Remember, this person picks at first. So the first selection. So the first selection. So we have red and green. So this is the first selection. Okay, this is the first selection, the first picking. So what's happening here? So we need to fill in these roots with probabilities. So this is what we do. At first, when this person picks, what is the probability? What is the chance that the ball that they've picked is red? Okay, so the probability that the ball they've picked is red is equal to the total number of red balls in the bag divided by the total number of balls. Okay, so the probability that the ball is red will be total number of red balls you can see is 7. So it will be 7. So you fill in here 7 over 9. That is the chance that maybe what they picked was red. But maybe this is a game of chance. Maybe what they picked wasn't red. What they picked probably was green. So what is the chance that what they picked was green? So we shall say the probability of picking green will be the total number of green balls there is 2 divided by the total number of balls, which is 9. So we are done with the first selection. So in the first selection, it's either they picked red or green, and these are the probabilities. Then let's now go to the second selection because this person continues. But remember, once they pick at first, they are not replacing. So if you don't replace, you're going to change the total number of balls that remain in the bag. So what will happen in the second selection? So let me show you. So second selection now. So let's assume what they picked was red. So if what they picked at first was red, what do you think they can pick secondly? So what they can pick secondly is either they will still pick red or they can pick green. Because it's a game of chance. If you pick red at first, you're not so sure that you're going to pick red again. So it's either you pick red again, yes, or you can also pick what? Green. So we're going to say, after picking red, the second selection can happen in two ways. It's either they pick red again, this is the second selection. They pick red, or they can pick green. So this is the second selection. So this is what will happen. Now we need to fill in these roots with probabilities. So remember, what we're assuming here is that at first we picked red. So don't worry about this. We'll come back to this. Let's handle this first. So if we picked red at first, remember this person is not replacing. So if you pick red at first, it means the number of red balls have reduced. We no longer have 7 here. The number of red balls will now be 6. So 6 red. But the green balls will still be 2 because we are assuming that here we only picked red at first. So we still have 2 green balls. Okay? Now, if you add this time around, you see that the total will now be what? 8. So what will be the new probabilities here? Let's fill in the probabilities. So we shall say, what is the probability of picking red this time? So the probability of picking red, given that at first we picked red, so the probability of picking red now, you see, how many red balls do we have in the bag this time around? We have 6 of them. Then divided by the total, which is 8. Okay? Then, maybe we picked red, yes, at first, but maybe this time around we're going to pick what? A green ball. So it means that the probability of picking green will be the total number of green balls, 2, out of 8. Okay? So picking red at first, you see that does not affect the number of picking red does not affect the number of green balls. It will only affect the number of red balls that will remain in the bag. So we are done with the second selection for this route. Let's now assume that actually what we picked at first was not red, was green. So we're going to have another route here. Okay? So we forget about whatever has happened here. Let's forget about whatever has happened. Let's just assume that at first we picked green. So if at first we picked green, what will happen in the second selection? It's either we pick green again, okay? We can pick green again. So we can pick green again, yes. Or we can pick red. Yeah. So if we picked green at first, what do you think will happen here? Forget about what happened here, okay? So if at first we picked green, what will happen is the number of green balls will change, okay? But the number of red balls will still be 7. So 7 red balls because we picked green at first and we did not replace the green ball back. Okay, then the number of green balls will now be 1 because we had 2, then we've picked 1 and we didn't replace it. Then total will be 8. Now, what will be the new probabilities here? So the new probabilities here will be, what is the probability that we are going to pick green again? We shall say, how many green balls are left in the bag? 1. So to be 1 out of the total number of green balls. I mean, total number of balls in the bag, which is 8. So 1 over 8. Then what is the probability that you're going to pick red? We shall say total number of red balls in the bag, 7 out of what? 8. So this concludes all the routes, and this is how you draw a tree diagram. Okay? So this is your second selection, remember? This is a second selection. Okay. Then here, the outcomes. Let's write down the outcomes. Okay, you can see here, this outcome will be red, red, What I mean here is that it's the probability that you are picking red at first, then again second red. Then here, at first you pick red, then second you pick green. Then here, at first you pick green, then second you pick red. Then here, at first you pick green, then second you pick green. So this is your tree diagram, and that's how you draw it. That's all. And usually when they ask you to draw a tree diagram, they will give you 3 marks. Okay, now after drawing our tree diagram, what follows? Okay, when we draw our tree diagram, the questions become easy. Okay, so the question now will say, find the probability that the 2 balls picked are both green. Remember, we're picking 2 balls. What is the probability that the 2 balls that we've picked are both green? So if both of them are green, what it means is that at first I picked green. Secondly, again, I picked what? Green. So I want to find the probability of green, green. So I just use my tree diagram here. I just want to look at my tree diagram. Where do I have green, green? So green, green is actually here. So we want these probabilities. So we shall say, this is part 2A. What is the probability? Probability of picking what? Green, green. That's what we want. So probability of picking green, green will be equal to probability of picking green at first. So we want this root. This root is green, green. So green at first, 2/9. You multiply it by green at the second selection. So 1/8. So this will give us 2 there, 1, 2 there, 4. 1 times 1, 1, divided by 9 times 4, 36. This is the probability of picking 2 balls that are both green. The other one, what is the probability of picking balls that have the same color? So if we're talking about probability of picking balls with the same color, we shall say probability of picking balls, 2 balls with the same color, would mean maybe red, red or green, green. Okay? So we shall say this means probability of green, green or probability of red, red. You can see that. This is same color, this is same color. Now, in probability, when you see the word or, it actually means addition. Okay? Yeah, so it means we need to add up these 2 probabilities. So the probability of picking green, green, we already know green, green is this one, 1/36. Plus probability of picking red, red. So red, red is this root. You can see this root. So it means this times that one. So we're going to add this to 7/9 multiplied by 6/8. This is probability of red, red. So we shall have 1/36 plus, we can do some cancellation here. We can say 3 there, 2. 3 there, 3. 2 there, 1. 2 there, 4. 7 times 1, that is 7 over. 3 times 4, that is 12. And common denominator here is 36. So 36 into 36, 1 times 1, 1. Plus 12 into 36, 3. 3 times 7, 21. Okay. What am I getting here? So I shall get 22/36. But you know that 2 can go in both numbers. So 2 there, 11 out of 18. So this is the probability that the 2 balls picked have the same color. They can also ask you questions like, what is the probability that the 2 balls picked, at least one is red, at least one red. So at least the word at least would mean equal to or greater than. Okay? Equal to or greater than. What it means is that at least one is red means maybe one is red or both are red. So the number of red balls should be 1 or above. 1 or more. 1 or more. So in other words, everywhere you see a red is at least one is red. So at least one is red would mean, so at least one red here would mean probability of maybe red, red actually, plus probability of red green plus probability of green red. So you can see that it's actually this probability, this probability, this probability. So this you multiply plus this, you add them. Okay? Or you can see that actually what we are not including is this one. The total probability is 1. So meaning when I say at least one red, I can just say 1 minus probability of the one I'm not including, this one. Because the total is 1. So I can just say 1 minus this one. It will give me these remaining probabilities. So you can also calculate it using this way. Okay? Yeah. So you should be aware of such terminologies. Basically, this is how you do your probability. By the way, if maybe we had 3 types of things, let's say we had 3 colors, maybe 2 red, 3 blue, 5 yellow, okay? It means you're going to have 3 branches, okay? So we're going to have something that looks like this. Total, you can see the total here is, you add this plus that, it's 10. So it's like you have red, blue, yellow. Then you start filling in the probabilities. You can actually fill in the probabilities if without replacement, okay? Usually they will tell you without replacement. So at first, maybe here the probability of red will be 2 out of 10. Probability of blue, you can see it's 3 out of 10. Probability of yellow here is 5 out of 10. Then it means if we assume that you picked red at first, what will happen here? Maybe you can pick red, or maybe you can pick this, or maybe you can pick that. Even here, you do this. Even this one will have this. Then you fill in all these probabilities, then you'll be done. So it's very easy to fill in all these probabilities. If you say you picked red at first, it means that the number of red balls are the ones that will only change here. The other ones will remain the same. So if I pick red here, I know that the total has now become 9 because red is not being replaced back. So I know the total is now 9 and red will no longer be 2 but 1. So you're going to put here, this will now be 1 over 9. But the other ones here, the number of balls do not change. So this will just be 3, but the total, remember, has changed because we did not replace the red back. So this becomes 3 over 9. This becomes 5 over 9. You do the same here. Here you assume that actually what you picked at first was blue. So if what you picked at blue, forget about what happened here. It means the blue balls are the ones that will now change. So blue will now be 2 here. So it will be 2 over 9. Okay. Then these other ones will remain the same, meaning red will still be 2 over 9. Yellow will still be 5 out of 9. Then here you assume that what you picked at first was actually what? Yellow. Then yellow will no longer be 5 here, but 4. So yellow will be 4 over 9. Then the other ones remain the same. So this will be 3 over 9. This will be 2 over 9. Then you are okay. You are done. This is the first picking. This is the second picking. This is red, red. You put in the details. This is red, blue. This is red, yellow. This is all the details, you put them in like that. Then you'll be able to answer the other questions that will come in. Okay, let's look at another question. This is another way the examiner can ask a question on probability. Okay, apart from the tree diagram thing, they can also ask you in this way. A survey carried out at a certain hospital shows that the probability of a patient testing positive for Ebola is 0.2. Find the probability that the 2 patients selected at random from this hospital both test negative, one tests negative while the other positive. Okay, so they carry out a survey and find out that the probability that a patient selected at random from this hospital testing positive is 0.2. Okay, then we are asked to solve these questions. So the probability that the patient tests positive is 0.2. What do you think will be the probability that the patient tests negative? So what I want you to know is this rule. Probability that event A happens plus probability that the same event does not happen should give you total 1. Probability of A plus probability of not A should be equal to 1. Meaning, if they give me, let's suppose they say, oh, the probability that I will pass the exam is 0.6. What is the probability that I will not pass? It will be 1 minus 0.6, which is 0.4. So it's the same thing here. Probability that the event A will happen plus not A should give you 1. If I say probability of A is 0.7, then probability of not A will be 1 minus 0.7 or 0.3. The same thing here. They've told us that the probability that a patient would test positive is 0.2. What is the probability that the patient will test negative? It will be 1 minus 0.2 or 0.8. So first of all, before we even answer this question, we need to know that if they've given us that, oh, probability that the patient will test positive is 0.2, you should also know the probability of testing negative before you even start answering. It's the same thing when they ask you, oh, at a certain school, a survey shows that the probability that a student will be late for class is 0.7. You should know that what is the probability that the student will not be late for class. So 1 minus 0.7, 0.3. That is how you should be thinking in that angle. Okay, so we know that probability of testing here in this, we already know probability of positive 0.2. So probability of negative, you should know it, will be 1 minus 0.2 or 0.8. Then let's answer the questions. What is the probability that both patients selected from this hospital test negative? So 2 patients both test negative. So what do you think will be the chance? So if both test negative, we shall say probability that both are negative, both n, will be equal to probability of the first patient being negative multiplied by the probability that the second patient is also what? Negative. Because they've said both patients negative. So it's negative, negative. We already know the probability of testing what? Negative. Probability of testing negative is 0.8. So the first patient, what is the chance that the first patient will be negative? 0.8. How about this one? 0.8. Then we multiply the two. So it will be 0.8 multiplied by 0.8. And this will give us, because 8 times 8 is 64, so it will give us 0.64. Okay, if you want, you can use your calculator, because this is mathematics paper 2 and you are allowed to use your calculator. 0.64. Okay, so that is the answer. Okay, the next question. What is the probability that these 2 patients selected at random from the hospital, one tests negative while the other tests positive? So what is the chance that one is negative while the other is positive? So we want to find probability that one should be negative, okay? Then the other should be positive. So 1 negative, 1 positive. So what do you think will be the result? So I picked 2 patients at random. Maybe the first patient that I pick, I just want one to be positive, the other one should be negative. So the first patient, let's suppose the first patient is a negative. Then the second should be what? Positive, because one should be negative, the other one no? Positive. So if the first patient is negative, then the second should be positive. Is this the only way? No, we can also have another order. Maybe we started with the positive patient. So, or probability that the first one is the one who is positive, then the second should be negative. Like that. So this will give you a situation where you have 1 negative and 1 positive. You can see in every case we have 1 positive, 1 negative, but the order matters, okay? The order is different, because maybe here at first we selected a negative patient, then we selected the positive patient, or we actually started with the positive patient, then a negative patient. So, but remember what I said about or. I said or means addition. So you need to add up these probabilities. So let's find this. So probability of n times z, probability of p, we know P is 0.2, N is 0.8. So we multiply this first of all. So 0.2 multiplied by 0.8. Then O means addition. So we add. This, we know probability of okay, the order doesn't, I don't want to confuse you here. Probability of negative is 0.8, but the result will still be the same. Then plus, probability of positive here is 0.2 so times 0.8. Okay, we are almost there. Okay, so this will give us 0.16 plus this will also give us 0.16. And overall, this will give us 0.32. Okay, so you can just confirm with your answer. 0.8 times 0.2, 0.16. You add the two, you're going to get 0.32. So this is a probability that one is positive while the other is negative. Okay, so this is all for probability. Okay, if you have any questions, you should let me know in the comment section. Okay, just watch out for the next video where I will explain about these other questions. Yeah. These other questions, okay? Computer, vectors, yeah. Yeah, so just watch out. I don't want to make this video long, so let me just cut it now so that I can make another video where I'll explain about it. These other questions. So bye-bye for now.